Every day, more than 4 billion space objects, also known as meteoroids, descend into the Earth's gravity well. This term refers to anything larger than cosmic dust, but smaller than an asteroid. Most of these are tiny stones that swiftly combust in the Earth's atmosphere. Few people can get through this obstacle. When a meteoroid touches Earth, it is referred to as a meteorite. They do not, however, present a special threat. However, occasionally, they can frighten locals, as they did in 2013 in Russia in the Chelyabinsk accident. However, that was just a meteoroid colliding lightly into the Earth's surface. What if we make things a little crazier by increasing the speed of the meteoroid to the speed of light? Stick till the end of the video to find out. No mass-containing particle is physically capable of transporting at the speed of light. But for our needs, this is irrelevant. It will only be just enough approaching the rate, little to startle the entire system. But we will get to that in a minute. Suppose that you have a round, 30-meter diameter diamond ball that you have just fired at a speed of 3,000 kilometers per second in the vicinity of the Earth. First off, it should be mentioned that at such speeds, nuclear fusion starts to take place in our atmosphere's air. Additionally, the plasma heating could potentially destroy our diamond orb before it reaches the Earth. But we won't let Earth win us over. The spherical won't go far enough and will eventually collide with the Earth. The impact will produce a 1,000 times greater energy release than the most potent nuclear bombs ever. Additionally, the area immediately surrounding the collision will be completely cleared. However, this is not as crazy as we expected it to be, right? That is because it is only the impact of 0.001 speed of light. It will be a massive crater. Stone will scatter at 0.99 the speed of light due to this heat. Relativistic consequences are starting to emerge in this situation. Bonds that keep the sphere together as a whole are completely broken. When a diamond meteorite breaks down, just carbon atoms remain. The sphere moves so quickly that a Lorentz compression deflates it into a pancake. Of course, we wouldn't be able to see this with our eyes. About 70 billion electronvolts of energy are contained within each carbon atom in the sphere. They travel too quickly to pass directly through the air without colliding with it. The 3-meter diameter of the sphere allows air molecules to enter, where they become trapped. It speedily swells and contains more matter when it arrives on Earth than it did at the start of its descent. It fully crumbles when it contacts the surface. Cleaving the Earth caused the formation of a large, deep, hollow, and cone-shaped tube through the lithosphere. The collision's strength will shatter a hole in the Earth's mantle and create a pit that is so huge that you should be able to see the molten mantle through it. The radiation emitted by the crash will be 50 times greater than that of the Chicxulub asteroid, which destroyed the dinosaurs in Mexico. This is sufficient to bring about a major catastrophe, if not the complete elimination of all life. Would you enjoy seeing such a magnificent performance? We prefer not. Are things not still as crazy as you expected, right? Let's increase the speed a bit again. How about 99.999999% the speed of light? The energy stored in each carbon molecule has increased to 25 trillion electron volts. It can be compared to the particles in the Large Hadron Collider's beam, LHC, found in Switzerland. This will impact the Earth under such circumstances with kinetic energy compared to the Moon orbiting the Earth. This is sufficient for the Earth's mantle to rupture massively and to cause the surface to burn entirely. there is a much higher likelihood that this will exterminate all life on Earth. However, we are still not there yet. Let's take it up a notch. This time, let's see what 0.999999999999999% the speed of light, which is 9,951%, could do. It will be possible to find the velocity of the "oh my god" particle, as it is informally called, which is the fastest mass-containing object ever seen by humans. And no, before you put the guilt on God, let's clear one thing up. A space-borne proton that crashed into the atmosphere above Utah in 1991 is known as the "oh my god" particle. Furthermore, it was moving nearly at the speed of light. The speed of light is 21 times 99951% after 99 points. Even the Large Hadron Collider could not duplicate the particle avalanche created by its collision. The same phenomenon is observed multiple times a year, but nobody knows how it's created. They appear to originate from the vague direction of the galaxy explosion. However, what transpired there to prompt this hasty departure, and why did they slow down before arriving here? Let's generally leave this puzzle to the scientists and assign our diamond orb the "oh my god" particle's velocity. The meteoroid will fly so quickly that it will be impossible to model with modern computing technology. As a result, we can't predict how things will come out. But in broad, we can sketch out the picture. Without recognizing it, our diamond ball flies through the stratosphere before dissipating into the Earth's mantle. From the entry point, a cloud of rising plasma and concomitant radiation detracts, while energy pulses through the planet's core outwards. The entire planet's far side extends outward in the shape of a luminous cloud 40 milliseconds later. The diamond meteorite and the avalanche of particles it produced when it struck the crust of the Earth dispersed throughout the planet. The planet begins to broil and glow more brightly than the sun. The Earth will be pushed into a different orbit by such a collision, but it won't matter. Earth no longer remains. The energy of the planet's magnetic limit is 10,000 times lower than that of the precipitated matter. As a result, the Earth erupts into an enormous plasma cloud, and particularly intense fluxes shoot into the cosmos in the impact's trajectory. The sun is nearly choked by the clouds of dust that surround it, and the enormous high-energy plasma shock is hanging to light on the surface of nearby planets. And within a matter of a few magnificent fireworks, the Earth will be gone, and life will no longer exist in the universe. Let's sum things up a bit. With a speed of 10% of light, it would have the same energy as the 2013 Chelyabinsk meteor. It would light erupt in the upper atmosphere, breaking several windows, producing a large flash, etc. With 90% of the speed of light, its energy would be equivalent to a few meteor craters traveling. A tiny US state would be flattened, and the US would be covered in dust. It would have an energy equivalent to the Krakatoa explosion of 1883, traveling at 99.9% of the speed of light. Flatten a sizable state, and the US would be covered in rubble, severe dust, crop problems for a few years, etc. It would have many times more energy than every nuclear bomb on Earth if it traveled at 99.9999% of the speed of light. It would demolish a small country, scatter debris across a sizable portion of the globe, cause tsunamis, usher in a possible decade-long nuclear winter, etc. It collides with the Yucatan Peninsula's Chicxulub crater, with approximately the same energy as it does at 99.999999% of the speed of light, most likely eradicating all life on land and in the sea within a few months or years, causing plant death, etc. A couple more nines would enable it to convert the planet's surface into lava and boil the oceans dry. After a few more nines, it impacts with enough intensity to stop Earth's orbit, most likely ejecting the planet's surface into space and creating a new moon. Before it has enough momentum to match the magnetic pull of the Earth, it will take around 29 seconds. When that happens, it will be the moment of fatality.